This review is on integration. Going to start out Barron's Test 1, number 13. Okay, so I have the integral of pi over 2, from pi over 2 to pi over 4, or pi over 4 to pi over 2, of sine cubed alpha cosine of alpha d alpha. Okay, so this is the definite integral. We're going to integrate it, and then we're going to plug in our values and subtract and find what the actual value is. This is when you need to remember when we did trig, and we talked about if there's something being done to the trig, then your u is the trig. So this is a sine cubed, and it has an extra cosine. So I know that I want my u to be sine. I'm going to change the alphas to x's. U prime is the derivative of sine, which is cosine. So now if I do my u substitution and replace it, I've got u cubed u prime. So now it's just a power rule. So I have 1/4 u to the 4th. Then plug my u back in, and I have 1/4 sine to the 4th x from pi over 4 to pi over 2. So now I'm going to plug in. So sine to the 4th of pi over 2 minus sine to the 4th pi over 4. All right, pi over 2 is due north, and sine at north is 1, and 1 to the 4th is 1. Sine of pi over 4 is root 2 over 2, and then I need to raise that to the 4th power. Okay, well if I have root 2 times root 2 times root 2 times root 2, that would give me a 2, and that would give me a 2, so that's a 4. And then 2 to the 4th is 16, so that's really a 1/4. And then when I do 4/4 minus 1/4, I get 3/4. So that's 3/16. And again, if I'm going too fast, just pause it, go back through it, take your time, write it down. Make sure you're solid on these. Okay, the next one we're going to do is number 14. And I'm going to come down here. Okay, so I have the integral from 0 to 1, e to the x, 3 minus e to the x squared dx. Can I erase this a little bit? Okay. So we have to think about what we want to let u be. And u is always the thing that has the most meat on it. What has the most going on. So I'm going to let my u be 3 minus e to the x. And I know it's squared, but I'm just going to let my u be squared. Because then I know that u prime, well, the derivative of 3 is 0. And the derivative of e to the x is just e to the x, ln of e, which is 1. It is going to be a negative. So the only thing I need to come in here and add is a negative to compensate for that. So negative. Now I have a u prime on top and a u squared on the bottom. Okay, well I'm going to rewrite this and use my power rule to integrate. Okay, so if I add 1, you got to be careful with your -2. I'm adding 1 to my power, so that makes it a -1. So I have this negative times the -1 that I'm bringing down, so that's a +1. And then u to the, and then add 1, -1. So what just happened is I took this negative right here, and then I did 1 over, and I added 1 to my power, and that all washed out and gave me a positive 1, which is sitting right there. So I have u to the negative 1. Okay, so now I'm going to plug my u back in. So 3e to the x to the negative 1. Oh, sorry, 3 minus, which is 1 over 3 minus e to the x. And I'm going from 0 to 1. Okay, so if I plug in a 1, e to the 1 is just e. And then minus. Now I'm going to plug in a 0. Well, e to the 0, anything to the 0 is a 1. Okay, so that becomes a 1/2. Okay, and I'm trying to keep an eye on my answers, and they are all one big happy term. Well, I have 2 not happy fractions. So I'm going to go common denominator. So he's getting a 2, and he's getting a 3 minus e. Watch out, this is a shark. So 2 minus 3 plus e over 2, 3 minus e. And then the 2 minus 3 gives me negative 1. Okay, now look at your answer choices. So I have a negative 1 and an e on top. And I don't see that. And I have a 2 and a 3 minus e on the bottom. I don't like any of these. Now, it's always difficult to go out on a limb and choose the none of these, but you know, our math is solid. That's exactly what the answer should be, is right here. That's not one of my choices, so I'm going with none of these. Okay, the next one we're headed towards is number 18. Is an interesting and simple problem. I'm going to take you back to the days of pre-cal. Okay, so I have the integral from 0 to 6. That's a 6. The integral from 0 to 6. Okay, so what does it mean when you have a negative 1 inside your function? Because if you'll look, all your answers, except for him, are just plain old f of x. Okay, so what does that minus 1 do to this function? Well, that shifts it right 1. Okay, so whatever f of x was, it has been shifted right 1. And my integral is from 0 to 6. Well, that means if I go back to my original function, I'm going to be coming back 1. So what's that going to do to these guys? Well, it's going to make him a negative 1, and it's going to make him a 5. Again, this is shifted right 1, so he's here. To get back to your original f of x, he would have been here. So you're going left 1. So I have to take 1 off of my integral. Okay, next one is 35. In a marathon, when the winner crosses the finish line, many runners are still on the course, some quite far behind. If the density of runners X miles from the finish line is given by that, runners per mile, how many are within 8 miles of the finish line? Okay, well, I'm going to take, I want to know it's the density word that gives it away. Density is sort of like an area. I want to know how many people are there from 0 to 8 of this big, nasty, oh, one too many zeros. Okay, well, this would be on a calculator active section. So I'm just going to type it in. So I'm going to go math down to integration I'm going to plug in my 0 and my 8, and I'm going to oh so carefully plug this in with all of its powers and parentheses and brackets and double parentheses, and just be super, super careful. Type it in. You should get 166.39. So pause this, go type it in, and make sure you're getting 166. Okay, the next one we're going to is number 37. Okay. Now these were really, really easy, but you've got to catch them. You've got to know what it's asking for. Okay, this is an integral. It's asking for the derivative. Notice that it starts at 0 and ends at a variable, actually a function of the variable. Okay, so this was super, super easy. You just take, it has to start at 0. You take this upper limit guy, plug him in for x. So 1 over 1 plus, what is that, t squared? So t to the 4th. And then you times this by the derivative of what you plugged in. So 2t. So d. Super, super easy. You just got to remember how to do it and what you're looking for. So again, you're given the integral and you want the derivative. So what you're doing is you're taking the derivative of the integral. So you just take this top number, plug it into your x, but then don't forget to multiply by the derivative of that top number. Super, super easy. Okay, the next one we're doing is number 38. There's no product rule for integration. So I can't, leave it, take the derivative. Like I can't do that like I can do for derivatives. So for integration, I need it to be as cleaned up as possible. So I'm going to use some power rules here. I've got x to the 1/2 minus 2 times x squared. And so then if I distribute, when you multiply, you add your powers. So that'd be 5 over 2. Okay, so now I can take the integral, technically. I can take the integral of this. So let's see, 1 over, okay, add 1 to my power, so 7 over 2. And then add 1 to my power. And it's not a definite integral, so you've got to remember your plus c. So that'd be 2 over 7. Which is E. Yep. So just don't forget to go clean, because then it's really easy. I mean, it's kind of fractiony, but it's not difficult. Okay, now we're headed to Barron's 2, number 11. Barron's 2, number 11. Okay. Kind of makes you think maybe one of those inverse trig guys, but then if you stop and look, you've got an x on top. And with the inverse trig, you don't have an x on the top. So you're just going to go regular U-substitution here. Again, let your u be the guy that has the most meat on it. So I'm going to let the u be that. And now I can see when I go u prime, so there's the x that I need. I just need this extra -2. So I'm going to give them a -1/2 in the front. And then I'm going to have u prime over u to the 1/2. And before you try to make this like crazy difficult, just use your power rules. Pop this guy up and then use your power rule on it. So 1 over, okay, add 1 to that, so that'd be a 1/2 u to the 1/2 plus c. And then, so that'd be a negative 1/2. Bojangles that'd be a 2. And then that would be a negative u to the 1/2 plus c, because the 2's cancel. Now put your u back in. Let's see, my u was 9 minus x squared. 9 minus x squared to the 1/2. I bet they put that back under the root. Okay, so I'm looking for a negative 9 minus x squared to the 1/2. Looks like C. So here they're tempting you to do the trig. Here they're tempting you to do some sort of u prime over u. Well, for your natural log, that's not what I have because my u is to a power. So that's not what I have there. Okay, so that was 11. Now we're going to do number 12. Okay, number 12. And this is one, back in the day when we learned this, y'all tried to make this so much more complicated and you tried to use U-substitution. But remember, when you have a single term on the bottom, like if I take the top and write it twice and lobster it out and then divide everybody by 2y and sort of create these individual islands. And if you look at the answer choices, you kind of get the feel that they were all their individual, except for D, but all the other ones seem to be very individualized. So I'm going to lobster him and put him over 2y. And then I'm just going to divide them all by 2y. So that would be y over 2 minus 1 plus, and then I can do this as a 1/2 y to the negative 1. I already know that when I have a single y on the bottom, that's going to be ln. So you could also think of this as a 1 over 2y or a 1/2 1 over y. They're all the same thing. Okay, so now when I come in here and I integrate this, this is going to be, okay, 1/2 and then 1 over, okay, now take the power of the y, pull it down and add 1, and then add 1 to your power, and then minus, okay, well, the antiderivative constant just gets a variable, and then plus, okay, now I'm kind of leaning this way. If you're doing u substitution, if you let u be y, u prime is 1, which I have. There's my u prime, there's my u, I have this extra 1/2, and that's ln of y. And then technically plus c because it's not definite. So let's see, I look to have a 1/4 y squared, I'm liking that, minus a y plus a 1/2 ln of y. Yep, I like him. So just be, make sure you're super good on this and remember that, or u prime is natural log of u. So if u is the only thing in the bottom with no powers, no nothing on it, and your u prime's on top, that's your ln. Okay, now we're going to look at number 13. Okay, so I'm going to erase this so I have room. Okay, number 13. Cotangent of x dx. Antiderivative. This is one of those ones that we don't use a lot. You probably don't readily have memorized. I know I didn't. Go back and look at your formula sheet, and yeah, this does mean that we're gonna have to really buckle down and memorize those sort of oddballs that we didn't use that much. The integration of cotangent is ln absolute value sine of x. And I'm going from pi over 6 to pi over 2. I'd love to just type this in my calculator, but it's low numbers, so I'm probably calculator inactive. And look at all your answers. None of them are decimally. So I've got to go, I've got to work this sucker out. So plug the first guy in, and then minus, plug the second guy in. Okay. Sine of pi over 2, that's north. Sine of north is your y value, that's a 1. And ln of 1 is just ln of 1. E to the, yeah, minus. All right, sine of pi over 6. Ugly, pretty. Sine is the y value, so 1/2. Okay, not a choice. Okay, well, let's think about our log rules. Subtraction goes to division. So ln of 1 over 1/2, and then when you Bojangles that, ln of 2. There it is. So remember your log properties. And just because you look up and you don't see your answer, don't jump ship. Sometimes you just got to stick it out. Okay, we're going to 26. And I'm trying to pull all the harder ones to do with you so that you can do the simpler, straightforward problems on your own for homework, so you'll have less issues. But that doesn't mean you don't need to know how to do these. So make sure, take your time. Okay, so number 26. Again, going to U-Substitution. I'm going to pick the thing that has the most meat on it. So I'm going to let U be ln of x, not with the cubed. I'm going to let it be U cubed. So my u prime, okay, so the derivative of ln of x is dov over of, so that's 1 over x. You should remember doing these. See the x on the bottom right there? That's your 1 over x, because he's 1 over x. So what I have right now is I have the integral of u to the third, not over u prime, but times u prime, because remember, u prime is 1 over x. Make sure that makes sense. So now I'm just going to use my power rule. And I'm going from 1 to e. Let me put my u back in here. Oh, to the 4th. From 1 to e. Okay, so 1/4. ln of 2. No, not a 2. Where'd I get a 2? Oh, that's an e. ln of e, sorry, to the 4th minus ln of 1 to the 4th. Okay, ln of e is 1, because it'd be e to the something equals e. So that's a 1 to the 4th, which is 1. And ln of 1 is 0. So that's 0, that's gone. That's just a 1, and 1 times a 4th is a 4th. There you have it. Okay, now we're going to Barron's 3, number 6. Barron's 3, number 6. Okay, all kinds of trig. So look at it, think about it. Sine's got stuff, cosine doesn't. I'll let my u be what's on the bottom. So u equals 4 plus 2 sine. So u prime, 4's gone, 2 times sine, so 2 cosine x. Okay, so u is the bottom, u prime is the cosine. He needs a 2, so I'm going to give him a 1/2 out front. So now this is what I have. I have u prime on top over u. Okay, now we just talked about this one. When I have a plain old u on the bottom with no powers and a u prime on top, that's my ln. So I have 1/2 ln of u. Now let's put u back in here. U is 4 plus 2 sine x plus c because we're not integrating it. So let's see. I don't see that anywhere. I see a 1/4. 4 plus 2. I see a 2. I don't want a 2. I want a 1/2. Okay. Well, what if he's a power? I mean, he's out front, so he could be a power. If I kick him up as a power, then that would be ln 4 plus 2 sine x plus c. So not this one, because he doesn't have the ln. I don't know what that one's doing. ln square root. Yep. Got it. So again, don't panic. Patience. Stick to your guns with your math, and stay with your answer and just see it through and use your log properties. Okay, now we're headed to number 13. Okay. Let's see. This is one of those little inverse guys. See how you got the 3 inverse tangents down here? Yep. Yeah. Okay, so he's the tangent. Tangent's the one that doesn't have the root in it. So grab your formula sheet, look at the tangent guy, the inverse tangent on the back on the derivatives. I'm going to let my u, because u is the whatever that's sitting here that's squared. So that's e to the u, because that's what's being squared. My a is a 1, and then you can see that my u is sitting on top. So let's see, 1 over a, so 1 over 1, tangent inverse of u, which is e to the u, over a, which is 1 plus c. So 1 over 1 is 1, so tangent inverse e to the u plus c. Inverse e to the u plus c. That's D. Tangent seems to be the one of those that's popping up the most. So if you're going to pick one of them to memorize, I would memorize him for sure. Okay, we're going Princeton 19. Sorry, Princeton 1, 19. Princeton 1, 19. Cannot read that. All right, let's see. Integral, of course. Let's try that again. Integral E3 ln x plus E3x. Okay. I'm going to separate these into 2 separate. I mean, I know that's how you think about them anyway. But I'm just gonna see them. Okay. This guy, the first guy, there's some rule about e to the ln of x is just x. But you have a 3. So that would be x cubed. Because this becomes the x and the 3 is still sitting there. That's one of your log properties. Okay, well that's easy. That's 1/4 x to the 4th. Okay. Plus, okay, now this one, I got to use some U-substitution. U would be my 3x. U prime would be my 3. So he needs a 3, so I'm going to give him a 1/3. And that would be e to the u, u prime. And that is just e to the u. E's are easy. But my e to the u is e to the 3x because that's my u. And then plus c. So that. Let's see. D. Okay, so couldn't have done this problem if we didn't remember that. So e to the ln of x is x. Or e to the ln of something is the something. That's the rule. All right, now we're going 27. This one's tricky. I started doing this one. I was like, oh, well, I can distribute and just use my power rules, but you can't because the x plus 3 is being raised to the 1/2. So I can't distribute this and make them separate islands. I'm just kind of stuck. Okay, well, I've always told you to let u be the stuff with the most meat on it. So I'm going to let u be x plus 3, so u prime is going to be 1. Okay, so let's plug in what we have here. I've got integral of x. I haven't done anything with him, so that's weird. But then I've got u to the 1/2, and then u prime is just 1, so we're good. So u prime. So the problem is I have these u's, and that's great. I'm ready to pull the trigger, do the power rule, but I have this x. I don't know if y'all remember. We did do one like this. Okay, so he is the issue. Okay, but look. Can I solve that for x? X would equal u minus 3. So if I plug my u minus 3, then that's my u prime. And then I can distribute. When you multiply, you add your powers. So 2 over 2, 3 over 2. 3u to the 1/2. And all that's times u prime. So now if I just do my power rules, 1 over 5/2 u to the 5/2 minus 3 over 1/2 plus 1 plus c. Okay, now I just got to clean. 2/5 u to the 5/2 minus, all right, if I flip, 3's will cancel. Okay, now all I have to do is plug my u back into my u. Let's see, what was u? X plus 3. So 2/5 x plus 3 to the 5/2 minus 2 x plus 3 to the 3/2 plus c. 2/5 x plus 3, 5/2. I'm liking B. Okay, so stop for a second. Once you finish writing all that down, go back and either listen to it again or at least walk back through it yourself to make sure. Now, if this was a derivative, I can do that all day long. But for integration, you gotta have a couple tricks up your sleeve. Okay, now we're headed to number 30. Okay, so I have tangent to the 6th. Oh. Let's try that again. All right. Tangent to the 6th secant squared. Well, tangent and secant squared is tangent's inverse. So remember, when you have powers on your trig, let your u just be the trig, not the power. So u prime would be secant squared. So that's that, and this is just going to be u to the 6th u prime. Then it's just a simple power rule. That's not a negative. So 1/7 tangent to the 7th x plus c. Nice. Okay, next one we're going Princeton 2, number 16. Princeton 2, number 16. Okay, let's see. I'll let my U have the meat on it. Okay, so I'm going to let my U be the power. Is that 3x squared? So then my U prime is 6x. Well, there's the x. This 7 is just extra. So just move, like in your mind, move him out of the way. Okay, so I have an x, but I need a 6. Okay, so if I need a 6, then I'm going to compensate with a 1/6 outside. But remember, you took the 7 out there too. So I have a 7, and I'm giving him a 1/6. And then integral e to the u prime. Well, taking the integral of e to the u is really easy. 7/6 e to the u plus c. So 7/6 e to the, what was your u? 3x squared plus c. So the 7 was extra, and he's there to kind of throw you off because you need a 6. And no, you don't need to turn a 7 into a 6. Just pull the 7 out and then give yourself a 6 and a 1/6 outside. 7/6. So this would be B. That was number 16. Now we're going number 30. Okay. This is the integral of tangent. This is one of those ones that we don't use that much, but you do need to memorize it. So go back and look at your formula sheet. He is negative ln of cosine of x. And I'm going 0 to 1. So negative ln cosine of 1 minus negative, so plus, ln cosine of 0. Okay, well, cosine of 1, well, 1's not on my unit circle. I don't know what cosine of 1 is, so I'm going to leave him in there. Does everybody see why? Like, 1 is not an angle. Like, I know pi over 2 and pi over 6 and 2 pi and all that stuff, but 1 is not a place on the unit circle, so I don't know what cosine of 1 is. Now, I do know cosine of 0. 0 is right there. Cosine is the x value, so that's going to be a 1. Okay, so let's see. Now I can't really do anything here. I'm kind of stuck. But ln of 1 is 0, because this would be an e, and e to the something that equals 1, the something would have to be a 0. Okay, so he's gone, basically. Okay, so I'm left with this little guy. And I see a cosine of 1 and an ln, but he doesn't have the negative. So again, I'm going to stick to my guns. Now, how would they have popped up with a little secant here? Well, secant is cosine on the bottom. And then looky here, you've got this negative. If the negative was your power, wouldn't that put cosine on the bottom? Which would give me secant. So I like C. Okay, now I'm headed to number 41. And again, if I'm going too fast, just pause it. Pause it, take your time, let it sink in. Going to number 41. Okay. So now let's see. I got one with a big old power on it and one without. So I'm going to let my U be the one that's being raised to the power. Okay, so now let's see what U prime would be. Let's see how this fits together. So the derivative of sine would be cosine, but then take the derivative of the inside, so that would be 2. Okay, well, I like that. That's that right there. I need a 2, so I'm going to put a 1/2 out front. And then this is my u to the 5th u prime. Okay, well, this is just a power rule. 1/6 u to the 6th plus c, because it's not definite. So 1/12. And then what's my u? Sine 6 2x plus c. Let's see. A. So I hope you're getting a feel for how to decide who to let your u be. Okay. Now we're going Princeton 3. And we're starting with number 1. Princeton 3. Starting with number 1. Okay, so I'm going from pi over 4 to x. Now, don't think that because you have an x up here that this is the one where you plug the x into your t and then take the derivative of what you're plugging into, because that's only when you want to find the derivative of the integral. And no way, shape, or form does this asking you for the derivative. It's just a straight up integration problem. Okay, so I'm going to let u not be the trig, but be the of, because there's nothing else going on here. Like if I let u be cosine of 2t, then my u prime's got to be a negative sign. I don't have a negative sign, and I can't pull one out of thin air. So let your u be your of. U prime's going to be 2, which means I need a 1/2. So I have 1/2 cosine of u prime. Well, that would be 1/2 sine of u. Not plus c, because I have a definite integral. From pi over 4 to x. And yeah, it's weird to have an x in your integral, but that's okay. So hold on, let me plug my u back in. So 2t from pi over 4 to x. Okay, so I'm going to plug my x in first. So 1/2 sine of 2x minus sine. Now 2 times pi over 4 would be pi over 2. So 1/2 sine of 2x, and sine of pi over 2 is 1. And if I look at multiple choice, looks like B. Okay, headed to number 20. Okay, I cannot read this little print, so I'm going to rewrite it. Okay, so I have the integral from 0 to pi over 2 of sine of 2x e to the sine squared x dx. Well, that just looks like so much fun. Okay. Well, I'm going to let my u be the of my e, or the power of my e. So u is going to equal sine squared x. Okay, so my u prime, now go power rule and then chain rule on this guy. So 2 sine x to the 1, and then do the chain rule, so the derivative of the inside would be cosine x. Okay, now bells and whistles should be going off. 2 sine x cosine x, that's a double angle formula. And then, oh my gosh, this right here, that's what it equals. So this is where your double angle formulas, knowing them, this is the very first one. This is the only one that you've got for sine. That this right here is this right here. So this is my u prime. So what I have is 0 to pi over 2 e to the u prime. Okay, well, the integral of e to the u is easy. It's just e to the u. I'm going to go ahead and plug my sine squared x back up in my u. And I've got to go from 0 to pi over 2. Okay, so now I've got e, let's see, sine of pi over 2 is 1. 1 squared is 1. Okay, then e to the sine of 0 is 0. And 0 squared is 0. So I have e to the 1, which is just e, minus, and then anything to the 0 is 1. Okay, 29. Okay, now pay attention to what it's asking. This is the integral, but it's asking for the derivative of the integral. So this is that really, really easy one, except that really, really easy one where you just plug the top number in for your variable and then times it by the derivative. Those have to start at 0, and this guy doesn't start at 0. Okay, so if I have to start at 0, so if I think about, if using this rule, I have to do that. Is that an x? Yeah, I have to do that. Okay, well, to get this, I really only want to go from 2 to 5. Well, I can go from 0 to 5 and then subtract out. What would I need to subtract out? If I want to be left with 2 to 5, then I need to take out 0 to 2. Let's see if I can make that clearer. If I want 0 to 5x and here's 2x, if I only want this piece, but I have to use integrals that start at 0, then I'm going to use this whole piece, and I'm going to subtract out this little guy. And it's going to leave me with what I want. And now both those start with 0, and that makes me happy. So now I plug my 5x in, and I take the derivative, so 5 cosine 5x minus 2 cosine 2x, done. Okay, 44. Okay, it says let f of x equal the integral cotangent from 0 to pi, and then it says if f of pi over 6 equals 1, then f of 1. Okay, when they give me this, they're giving me a point, x, comma, y. This is what I want. I need to find f of x. Now notice, this is not a definite integral. So when I finish taking the integration of this, I'm going to have a plus c. Well, to find this, I need to know what the whole function is. So I'm going to have to find what c is. And then once I find that, I can plug this in for x and y. And then once I have that, I can plug a 1 in and get my answer. Okay, too much. One thing at a time. Okay, so I need the integration of cotangent, and that's one of those ones that we don't remember that often. Go look at your formula sheet. He's ln sine of x plus c. Okay, and that's it. I'm done with him. That's it. Okay, I need to know what c is. This is f of x, and I need f of 1. So I'm going to plug a 1 in for that x, but I need to know what c is. Okay, well, it gave me a point. So y is 1. X is pi over 6. Now I can find c. So ln of, let's see, sine of pi over 6 is going to be 1/2. And then I stop here and try to see if I need to be clean or if I can go decimals. And these are nasty, ugly decimals, so I'm going decimals. So I'm going to subtract my ln of 1/2 over. And so on your calculator, you're just doing 1 minus ln of 1/2, and I got 1.693. Okay, so now I can take this function and I can find f of 1. I just have to plug a 1 in right there. So, and I went straight calculator. Again, it's decimals, so ln sine of 1, close some parentheses, plus 1.693. I got 1.520. I kind of wrote over those. So we're going with this one. Okay, last one. We're going extra number 32. Extra number 32. Okay, and this one you got to have some tricks up your sleeve. Okay, the antiderivative of cosine cubed. Antiderivative of cosine cubed. If I let u be cosine x, the derivative of that would be negative sine, and I don't have a negative sign, and I can't pull a negative sign out of thin air. So I can't do U-substitution with my cosine. Okay. Cosine cubed. Cosine squared, I could replace with 1 minus sine squared. That would get me a sine in my problem. So what if I took this and broke it like that? And then I took this guy and replaced him with the Pythagorean with 1 minus sine squared. Okay, now, well, I can distribute that. Like, let's make life easier. Cosine minus sine squared cosine x. I think I have an extra c in there. Okay, now think of it as two separate. Well, this front one's easy. That's just going to be sine. Okay, now for this next one, I got to do a little u substitution. Again, let your u be the one with the meat. That's going to be sine because he's got the power. And then u prime would be cosine. So now I have u squared u prime. Well, this is just your power rule. So 1, add 1, plus c, and plug it back in. And bring this guy down. Yep. Okay, definitely stop, go back, walk back through that one, make sure it makes sense. And think about how you would have started. Like I started it with u substitution and realized that that wasn't going to work. Cosine cubed, there's a lot of cosines in there. So if I pulled the cosine squared, I was able to go Pythagorean. Then the distributing and the looking at them as two separate islands, that's just something that you need to be looking for to make life simpler. Okay, your homework. Let's see. Barron's 3, 29. Princeton 1, Princeton 2, Princeton 3, and the extra. Now you can see from the notes that this was a high volume of problems, and your homework is a high volume of problems, but that's in proportion to what it is on these on Barron and Princeton's practice test. So, you know, it's going to be a pretty good chunk of your AP exam. So, and these are just real good number crunchy, know your rules kind of problems. We want to get these right. If you're going to miss one, go miss something hard. Don't miss these that are just formulas. Make sure that you know your formulas.